Before we open the project, I want to make one point clear. This course is focused on building agentic AI systems in C++, so I'm not going to teach the QML setup step by step here. Instead, I have prepared this complete Ops Copilot project and shared it with you, which means you can open it, build it, and focus on taking our local RAG application into the browser. If you would like a separate lesson that covers Qt, QML, and WebAssembly development from the beginning, please mention that in your course feedback because it helps to understand what you would like to learn next. With that context in place, we can open Ops Copilot as a Qt, QML, and C++ project and move to the same application into the browser. I'm selecting the single-threaded WebAssembly kit and using a release build because this is the version we want to publish, okay? Once the build finishes, Qt Creator starts a local web server and opens the application in the browser. The interface and the local RAG behavior are still coming from the same project, so we have not created a second web implementation just for deployment. The package web target is already part of the regular WebAssembly build, so I can leave the target on all and simply build the project again. Qt Creator refreshes the deployment package automatically, while the compiler keeps its generated files under build and collects the files for the web browser under dist. Okay? That distinction keeps the upload clear and easy to review before anything leaves this Mac. The dist folder is our complete published package, and it contains only 4 files. The build folder we just passed contains compiler output, so that's not I will upload. Here in dist, index.html is the page and loading screen. AppOps Copilot.js starts the compiled application, and QtLoader.js provides Qt's browser loading support. The larger AppOps Copilot WASM file contains the C++ runtime, QML interface, local corpus, and embedded assets. These files belong together, so I will keep their names unchanged and publish them in the same server directory. With the 4 deployment files confirmed, I'm compressing exactly that set into one archive. This gives us a single upload instead of moving the files separately, and it also prevents a large WASM file from being mixed with unrelated project content. Notice that I'm not compressing the source tree or the complete build directory. The archive contains only the static files that we just reviewed, which is the same package we're about to publish. Now that the archive is ready, I already opened cPanel's file manager and moving into the domain's public document root. I just drag and drop the archive file. Then I go back and I just reload this. And here we are. We have archive file here. Now, already uploaded here and extract the archive here, okay? After extraction, the same 4 files are sitting directly beside one another. I can remove the zip file here because the server no longer needs it. There's no backend process to start here, so cPanel only has to serve these static files over HTTPS. Well, the upload is complete here, but I still want to verify the application through the same public URL that a real user will open. I'm just gonna create a new private window, and here I just enter the URL here, like opscopilot.lexby.com, okay? The loading screen appears first, then the compiled Qt interface takes over and fills the browser. A quick network check shows the WASM file returning successfully from our domain. So the browser has received the application rather than a local development copy. With that delivery check complete, we can use the live interface and confirm that the actual application behavior is available online. So let us use the deployed application instead of stopping at the loading screen. The first conversation retrieves a complete C++ example from the embedded programming material. The second chat moves to an operations question and grants the response in the local runbooks, while the third chat shows that the same corpus can support a more conversational request. Each conversation keeps its own session state, and the sidebar lets me move between them without mixing their contexts. The responsive layout also stays usable as I narrow the browser, so the deployed experience is working beyond one fixed desktop size. So that's the complete deployment path. We built the existing Qt, QML, and C++ project for WebAssembly, collected the release into 4 static files, compressed that package, uploaded through cPanel, and then verified the public URL by using the application itself. The important point is that the behavior we tested locally is the behavior now running in the browser. We did not rebuild the product around a separate web stack, and we did not add an external service here. We published the same local application as a self-contained WebAssembly experience. So let's get started using our custom GPT. Well, here typing write me a hello world Python code. And let's see the output. Okay, it's just created a basic program with definition, and it's well generated, okay? And let's try another message saying generate me a JavaScript code. And here output's also correct and well defined. Alright, let's create a new chat. And then use the data examples, which says, today I feel bad and overwhelmed, okay? And the answer is, it sounds like too many things are competing for your attention at the same time, etc., etc. And it's okay. Starting good and answering correctly, okay? Then let's create another chat and use the first example. And it also generated well, and it wrote simple C++ hello world example. It's wonderful. So as a result, we are using local documents to get those answers. We are doing local lagging with 15 documents and chunk to 79. In that point, this is our simple GPT completely written in C++ with high performance. And absolutely you can add as many as documents you want based on the answers you wanna get.